Have you ever wondered what the very beginning sounded like? Close your eyes for a moment. Imagine a silence so complete it fills all of space because there is no space yet. Then imagine a single, pure note begins to sound. It is not a note you could hear with your ears, but something deeper, a vibration that is both sound and creation itself. It starts as a gentle hum, a single frequency that grows and expands, not into a room, but into existence itself. This idea that the universe began not with a bang, but with a resonant tone connects music with the cosmic story of our origins. Long before modern telescopes, ancient cultures tried to make sense of the cosmos, turning to the language of music to explain the order they saw. To truly grasp a universe born from sound, we must become comfortable with vibration, waves, and frequency. Think about a still pond on a calm day. Now, toss a small pebble into the center. Ripples spread outward in perfect circles. A ripple is a wave, a disturbance moving through a medium carrying energy. When you pluck a guitar string, the vibration creates pressure waves in air your ear reads as a note. A pure tone is a smooth wave. A chord is many waves mixing together. Simple, intricate, harmonious, or dissonant. Now, apply this simple idea to everything. In physics, from light to matter, waves and vibrations describe reality itself. In the first moments, the cosmos was a hot, dense plasma where tiny quantum jitters made pressure waves, in a real sense, sound through space-time. How can we be so sure these primeval sound waves existed? We cannot go back and listen, but we can see the afterglow. For 380,000 years, photons were trapped in a thick, glowing plasma. Sound waves rippled through this fog, squeezing and relaxing it as they moved. Then came recombination. Protons and electrons formed hydrogen, and the fog cleared. Light broke free and has been traveling ever since, stretched into faint microwaves. This glow is the cosmic microwave background, the universe's baby picture. It is almost uniform, yet tiny. 1 in 100,000 variations reveal the wave's imprints. By reading these echoes, hot compressions, and cool rarefactions, we reconstruct the early soundscape. We are quite literally listening to the echo of creation, like a violin note. The early universe had a fundamental and harmonics. The fundamental was the largest wave. Smaller harmonics fit 2, 3, 4, or more cycles across the same space. Their interplay set the exact pattern of hot and cold spots, the infant universe's timbre. Compressed crests tugged a little harder, drawing in more matter over time. Those seeds grew into stars and superclusters. Today, we see the cosmic web, filaments, walls, and vast voids, a frozen symphony in space. Great clusters sit where fundamental waves peaked. Finer filaments echo higher harmonics. The cosmos is, in a very real sense, frozen music, and we can read its score encoded across the sky. There is another beautiful idea, resonance. Push with the right rhythm and motion amplifies, match a natural frequency and vibrations can soar. In the early cosmos, certain waves synced with the universe's tempo and grew. Others fell out of step and were damped away. Analyze the CMB and a graph called the power spectrum shows distinct peaks, the fundamental and its harmonics. These resonant peaks are the smoking gun for cosmic sound waves. Their positions and heights reveal the recipe. Matter, dark matter, energy density, even the shape of space. Like naming notes in a chord, cosmologists read these peaks to learn exactly how the universe was tuned and how a nearly uniform plasma blossomed into galaxies. The thought that reality is musical is ancient. Pythagoras linked harmonies to simple ratios, to revelation that numbers shape sound. Kepler sought celestial harmony, and though his musical model failed, his math transformed astronomy. Mechanistic clocks gave way to modern cosmology. And the old idea quietly returned from deeper than before. Not planets singing, but space-time vibrating and an infant cosmos resonating. Even deeper string theory proposes tiny strings of energy, each mode of vibration a different particle. An electron is one vibration, a photon another. The orchestra of reality at the subatomic level. In this view, the entire universe is a grand symphony performed on infinitesimal strings, like using the at the subatomic level. In a fraction of a second, inflation stretched space like a conductor's downbeat. It smoothed the stage and amplified quantum jitters into macroscopic waves. For 380,000 years, pressure waves rippled, the universe's resonant phase. Then light was set free, carrying the snapshot with it. A quiet passage followed, gravity conducting in the dark. At last, the first stars ignited, a solo entering the score. Galaxies grew and merged, complexity rising. Inside stars, hydrogen and helium fused into carbon, oxygen, nitrogen. Then supernovae scattered life's elements. From stellar ash came planets, including a small, rocky world where the cosmic music gave rise to life and to minds that listen. Our story is beautiful, but incomplete. Stars, gas, and dust are only about 5%. The rest is unseen. Dark matter, an invisible scaffold we feel through gravity. It is the deep, resonant drone that lets bright galaxies play without flying apart. Then the tempo changed. Expansion began to accelerate. We call the driver dark energy, a mysterious pressure in space-time itself. We are listening harder. Bigger telescopes, sensitive detectors, chasing faint notes in the score. Each new measurement deciphers another line, clues that could transform our understanding of physics. These unheard melodies guide the symphony's final movements toward a faster, more expansive coda. Did the universe start as a sound? In a literal sense, no. There was no air, but in a deeper sense, yes, it began with vibrations, resonant frequencies, harmonics, overtones, patterns grew under mathematical laws, indistinguishable from the laws of harmony. Simple rhythms blossomed into breathtaking complexity, galaxies, stars, planets, life. The night sky is the physical memory of ancient music. The carbon in our cells and the iron in our blood were forged in stellar instruments. We are not outside observers. We are the melody, the universe becoming aware of its own song. Science, art, and music echo the same deep order. Next time, under a dark sky, listen with your mind. Hear the deep, silent hum of space-time, a 13.8 billion year composition.